Okay, good day everyone. Today we will be discussing about hypothesis testing about a population mean when the variance is known. Okay, so today we will studying the hypothesis testing. So this would be the first lesson in the fourth quarter. By the way, what is hypothesis testing? So hypothesis testing is actually we define that when you were in junior high school as an educated guess, but a hypothesis is the anticipation of the outcome. So for whatever outcomes that we anticipate, any of those can be our answer for the problem given. And it is important for a research or in a study to have a hypothesis. So we have different steps in hypothesis testing. So we have five. So one, we have to state the hypothesis or to formulate hypothesis. So we have two kinds of hypothesis. So we have the null hypothesis it and the alternative hypothesis. So the null hypothesis is the hypothesis in which the the two variables has no significant difference. Therefore, the two variables being compared is similar to each other or has a significant relationship to each other or difference to each other. And the last is the alternative hypothesis, wherein it is the opposite of the null hypothesis, wherein the two variables being compared has no significant difference. So later on in the in the examples given, we will have um, examples on how to state our hypothesis. Next is to choose the level of significance. So this is given in all the problems. Usually we have different kinds of level of significance. We can have 0.01, we can have 0.05, and 0.10 or 0.1. Okay. Next is that we need to compute our test statistic. So this will tell us um, that this will tell how is our data is graphed. Ayan. So next is the critical value. Yung critical value naman will tell us in which part of the normal curve or any distribution kung saan yung limit nung ating value. And lastly, we have our conclusion. Remember that in statistics, we need to give conclusions because this is the time we need to explain or to interpret our result. So let's proceed to the example. So using these steps, we will determine or we will know how to test our hypothesis. Okay. So first example. By the way, before we proceed, we have here the types of errors. So this would be given when we have our judgment. So this is important for us to know what errors do we commit when we test our hypothesis. So we have here the null hypothesis. By the way, the null hypothesis is denoted by the symbol HO or H sub O, while the alternative hypothesis is denoted by H sub A. Okay. So if our null hypothesis is true and we reject it, therefore it's a type 1 error. When we have a false null hypothesis and we reject it, therefore it is a correct decision. If we have a true null hypothesis and we do not reject that, it is a correct decision. By the way, class, we don't use the term accepted because technically we don't really accept the 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 false hypothesis. Instead, we just not reject it. So We don't accept the fact, but we will just consider it as true. Therefore, we don't really accept it. So we use the term not rejected in opposing to the word rejected. Going back, if the null hypothesis is true and it is not rejected, therefore it's a correct decision. If we have a false null hypothesis and we do not reject that, we have a type 2 error. Reminder that um, we are talking here we are talking about null hypothesis in this example. So what about if we have alternative hypothesis? Let's take for example, if we have a false null hypothesis or if we have a false alternative hypothesis or H sub A is false and we reject it, the alternative hypothesis is rejected, what does it mean? So we will just rewrite the statement in the form that we use null hypothesis. So in conversion, we have the null hypothesis is true and the null hypothesis is not rejected. So we will just negation if you can still remember the lessons in logic. So we will just negate the statement. So we have the null hypothesis is true and it is not rejected. So let's check the matrix here. We say that it is a correct decision. Therefore, it is a correct decision when we have a false alternative hypothesis and we reject that. Other example, what if we have a false null hypothesis, or sorry, if we have a false alternative hypothesis and we accept it, or we do not reject, rather. Okay, again, just simply convert our statement in a form that it is in the context of null hypothesis. Therefore, we have null is true and null is rejected. Now we can simply determine what error do we commit in this example. So therefore, we have what? A type 1 error. Remember, when determining the type of error that we have committed, make sure that it is in the context of null hypothesis. Okay. Moving forward, let's have here the example. So, example number 1. The leader of the Association of Jeepney Drivers claims that the average daily take-home pay of all jeepney drivers in Pasay City is 400 pesos. A random sample of 100 jeepney drivers in Pasay City was interviewed, and the average daily take-home pay of these 100 drivers, is found to be 425 pesos. Use a zero point 0.5 significance level to find out if the average daily take-home pay of all jeepney drivers in Pasay City is different from the 400 pesos given. Assume that the population variance is 8,464 pesos. So let's do the hypothesis testing. So step 1. Okay, so step 1. We will formulate our hypothesis. So our null hypothesis, which is denoted by H sub O, is what? We will just get the first claim or the first statement given in our example, which is the average daily take-home pay of the drivers or jeepney drivers in Pasay City is 400 pesos. Okay. As I said a while ago, when we say that it is a null hypothesis, therefore the variables being compared is similar to each other, or in the term of mathematics, it is equal to each other. Therefore, since this is the average daily take-home pay, we assume that it is the mean, 'di ba? Kasi average. So since we are talking about the jeepney drivers in Pasay City, therefore we are talking about the population mean here. Therefore, we can state that mu is equal to 400, wherein the mu is our population mean. And I believe that you are very familiar with this symbol, that we use the small Greek letter mu to indicate that the given is a population mean. What about our alternative hypothesis? Let's go back to the problem given earlier. The alternative hypothesis is something that would negate, or let's say counters what is given. Let's take for example, in the latter explanation, there is a random sample that 100 jeepney drivers is interviewed and the given data is 450. Okay, so that statement says that something is comparing, or let's say not agreeing with what is given above. So we will just see here or read here that um, or we will just check if really the average daily take-home pay of all the jeepney drivers in Pasay is different from what is given, which is 400 pesos. So that would become our alternative hypothesis, wherein the alternative hypothesis would be the average daily take-home pay of all the jeepney drivers in Pasay City is not equal to 400 pesos, or is not 400 pesos. So when we write that in mathematical form, we will be having mu is not equal to 400. There are some problem that we will be having specific comparisons, such as it might be greater than 400 or less than 400. But remember, in this example, we only see the word different. So we will just check if the given take-home pay or the average take-home pay is not equal to 400 pesos. So that would be our alternative hypothesis. So that would be for step one. For step two, determine the significance level. And the significance level is also known as the alpha level. By the way, this is the symbol for alpha. Okay, so the alpha level or the significance level is denoted by the symbol small letter alpha. And based on the problem given, our alpha level or our significance level is 0.5. Okay, let's proceed to step number 3. For step number 3, we need to compute for our test statistic. Okay, so when we compute our test statistic, and as you notice, the population variance here is given. So we will be using the formula for the z-score. So we have the formula for the z-score. It is x bar minus the mu all over small letter sigma over square root of n, wherein our x bar is the sample mean. Mu, of course, is the population mean. Our sigma here, small letter sigma, is the standard deviation, and n is the sample size. So based on the problem earlier, we all know that one claim state that they interviewed 100 jeepney drivers. So that would be n. So we have n is equal to 100. And then in the 100 jeepney drivers interviewed, the take-home pay, the average take-home pay is 425 pesos, wherein that would become our sample mean. Of course, for our sample population, we will just copy that from our null hypothesis. So that would be equal to 400. And of course, given that we have a standard deviation, and in the problem, the given is variance, which is 8,464, we will just get the standard deviation from the variance. And based on our discussion on the third quarter, we all know that the square root of the variance is the standard deviation. So when we square root the variance 8,464, the standard deviation is 92. Okay. Proceeding to step number 3, just simply substitute the given to our formula. So now we have 425 minus 400 over 92 over square root of 10. Compute this on your calculator. It will give us a z-score of 2.72. Okay. So this is our test statistic. For our step 4, we will get the critical value. So how do we get our critical value? First, check our alternative hypothesis. So our alternative hypothesis is H sub A. So mu is not equal to 400. So let's have here the matrix or the table. Okay, as you can see, our alpha level is 0. Sorry. Since the given here is not equal sign, we are using not equal sign. Therefore, the type of alternative hypothesis that we have is non-directional. So if it's non-directional, therefore, we will be using a two-tailed test. Okay. So if we are going to use a two-tailed test, we will be using another matrix. Okay. Going back to the alpha level, on step number 2, we have 0.05. So it's here. Now, check if it's what kind of test. So we have a two-tailed test. So find their intersection, we will be having 1.96. Therefore, our critical value for this example is 1.96. So that is for step 4, but we're not done yet. We will graph these z-scores. Okay, so we have here a normal curve. So since we have here the critical value, remember it's two-tailed. So if it's two-tailed, remember that our normal curve has two tails. So this one and this one. So plot the z-score. So let's assume that it is here. So this would be 1.96. So we will be plotting the other z-score here, 1.96, for us to have a two-tailed. So shade the tails.
Tanong ko lang, kasi nakita ko dito, si Ma'am Marwa, member na DRR response committee.
Okay. And then plot our z-score. So this is 2.72. So let's assume that the z-score is here, which is 2.72. Okay. Now, we will interpret the graph. So based on the graph, which is here. Ayan. So since the test statistic which is 2.72 lies on the tails, wherein this tails, by the way, is called the rejection region. So what is the rejection region? So the rejection region is these yellow regions or the tails. This is the rejection region. Why do we call this a rejection region? Because if the test statistic lies on these regions, we will reject the null hypothesis or the H sub O. So if we reject the null hypothesis, we will consider the other hypothesis to become the conclusion. And that leads us to step number 5. Since the null hypothesis is rejected, alternative hypothesis would be not rejected. And this would become our conclusion. Hence, our conclusion would be the average take-home pay of the jeepney drivers
sige, tapusin ko lang itong ano. Tapusin ko lang itong designations niya.
in Pasay City is not 400 pesos. So it could be more than 400 pesos or it could be less than 400 pesos, but not 400 pesos. Therefore, the first claim on the problem is not true. Okay, for our second example, so according to a study done last year, the average monthly expenses for cell phone loads of high school students in Manila was 350 pesos. A statistician student believes that this amount has increased since January. Is there a reason to believe that this amount has really increased if a random sample of 60 students has an average monthly expense of 380 pesos? Use a 0.05 level of significance, assuming that the population standard deviation is 77 pesos. Okay, so again, we will be using the steps in testing hypothesis. Okay, okay. So step one, okay, step one. What are the hypotheses? Okay, so okay, so what's the hypothesis?
Hello, ma'am. Yes po, ma'am. With regards
Okay, let us state the null hypothesis for step number one. So for the null hypothesis,
so far I have 109 yes.
okay,
The mga students
so we
natin.
have
So, are we going to push to
the average
Yes po, kasi
monthly
gusto ko muna i-ano din yung mga bata na
expenses
kasi baka mamaya yun nga yung
for mobile
more than
phones
50 na yes, tapos ganun pala yung
or mobile phone loads
basta push ko na kasi nag-message ko.
of high school students. Sorry, let me write that long.
Okay po.
High school students in Manila
Opo.
is
Yes po.
how much? 300 or yeah, 350 pesos. So that would be our null hypothesis. But do not forget to write the symbol. So what would be the symbol? The mathematical symbol would be mu is equal to 350. Now, let's check the second claim. So, if you have the copy of the problem,
Is this Sir Ariel po?
okay, so it is stated on the problem earlier that a statistic student believes that there would be an increase in the average monthly expense. So that would become our alternative hypothesis. So the average monthly expenses for mobile phone loads of high school students in Manila is what? Is greater than 350 pesos. Why greater than? Because on our second claim, it is stated that a statistics students believe that there would be an increase. So from 350, there would be an increase from that. So the average mobile phone loads would become more than 350. Sorry for the typographical error. Okay, so the symbol for this alternative hypothesis would become mu is greater than 350. Okay, so let's proceed to step 2. Okay, our step 2, what's our alpha level or the level of significance? It is 0.05. For step 3, let's write the equation or the formula for the z-score. Remember that we will be using this formula because the population variance is given. Okay, so if it's not given, therefore we will be not using this formula. Instead, we will be using a new formula, and that will be our topic next week. So the formula for the z-score is x bar minus the mu over the sigma over square root of n. Let's determine the variables given there. So we have x bar. So it is stated that the statistic student interviewed 60 students. So that would be our n, 60, and obtain an average monthly expense for loads that is amounting 380 pesos. Copying the mu, which is in our hypothesis, which is 350, and our variance, which is in the, sorry, our standard deviation, which is at the end of our problem, which is 77 pesos. Okay. Simply solve the formula. So we have z is equal to 380 minus 350 over 77 over square root of 60. Calculate the result. The resulting answer is 3.02. I hope that you have your calculator with you while we are discussing for you to follow. Okay? So our test statistic for step number 3 is 3.02. Now, we will be going to find the critical value. Just like what I've said earlier, the critical value would serve as our limit in our normal curve. So in finding the critical value, let's go back with the slide later. So we will just write first the needed information. So we all know that our HA, or the alternative hypothesis, has a mathematical sentence of mu is greater than 350. Since we are using greater than instead of not equal symbol, it is directional. And if it's directional, it is a one-tailed test. For us to confirm, let's go back with to the slide that we have seen earlier. As you can see, we have here a more specific inequality symbol. That's the reason why it is directional. And actually, class, we can use those symbol to determine if it's not directional, or sorry, non-directional or directional. If we use greater than or less than symbol, it seems that this symbols becomes an arrow, or it is like an arrow. It resembles an arrow. So it tells us direction. That's why it's directional. And if it's directional, it is a one-tailed test. Okay. Otherwise, if it is an equal sign or not equal sign, therefore it doesn't tell us direction. Therefore, it's non-directional. And if it's non-directional non-directional alternative hypothesis, therefore it's a two-tailed test to be used in our study. Going back in our example, ayan. So we will be using one-tailed test. Now, on our alpha level is 0.05. And since we will be using a one-tailed test, therefore, the intersection would be the value of our critical value, which is 1.645. Why do we obtain 1.645? Actually, class, it's from the table of normal, the table of the, sorry, table of areas of the normal curve. But for you um, to be, for you to to be easier for you to find the value of the critical value, I'll put a table for you to find it easier. Okay? So, yun. So, what is our critical value na nga? It is equal to 1.645. Okay. So, let's plot the table. So, for the critical value, let's use the yellow marker. Okay. So, again, what do we call to the yellow region? It is the rejection region. So as I've said a while ago, if the test statistic lies on the rejection region, we need to reject the null hypothesis and do not reject the alternative hypothesis. So in either of these hypotheses, so in Either, yeah, in either of these hypotheses, if it's rejected, then the other one will be used as the conclusion. So we have here the critical value, which is 1.645. Sorry, class. This is a one-tailed test. Therefore, we will just put one tail in the normal curve. And as I said a while ago, since it's directional, we need to find in which direction shall we create a rejection region. And the greater than symbol will tell us where. So since the greater than symbol is pointing to the right, as you can see here, therefore, it is where we should put our rejection region. So therefore, in the right side of our normal curve, it is where we should put our rejection region. So we have it here. Why right? Because it is greater than. And we all know that greater numbers are found in the right? Okay. So what's our critical value? We have 3.02. So here is 1.645. So where can we find our critical value? So let's create a statement. Okay. Since the what? Since the test statistic lies on the critical value, sorry, lies on the rejection region, we will what? Reject the null hypothesis or the H sub O. Hence, going to step number 5, we will use the other hypothesis, which is the alternative hypothesis, as our conclusion. So, the average monthly expenses for mobile phone loads of high school students in Manila is greater than 350 pesos. So this is for example number 2. For example number 3, let me read. The national news has reported that the average grade of a fifth grader in mathematics is 87. A math teacher argues that the actual average is less than the result. With the hypothesis, he tested 50 randomly selected students and obtained a mean score of 85 with a standard deviation of 2.5. At zero point 0.1 level of significance, test the teacher's argument. Okay, so let's have
Yes, ma'am, nasa MP na tayo, ma'am.
to test the hypothesis. So step 1, so we have the null hypothesis, the average grade of a fifth grader in mathematics is 87. And the alternative would be the average grade of a fifth grader in math is less than 87, as told by what? By the math teacher who argues the statement. So that would be our alternative hypothesis, which is HA. So we write it in symbol. For the null, we have mu is equal to 87. For alternative, we have mu is less than 87. For step number 2, we have that the alpha level, which is 0.01. For step 3, okay, we have the formula Z is equal to the x bar minus the mu over sigma over square root of n. Our x bar is 85. Our mu is 87. Our sigma is, okay, and our n is 60. By the way, class, I forget what is the sigma. So let me check first in our problem.
Yes po.
So, okay, it's 2.5.
Let us
And
all remember that we're the most depressed sexual.
let me correct that
Father, Father, good afternoon po.
the
We take you
mean
from
score,
lessons
sorry, the
about
sample
our
size is
upon us
50.
English list of recognition.
Okay, so simply substitute the given.
Thank you for
So we
sharing
have
that today. As we
85
do this activity
minus
for your benefit,
87 over
continue to join
2.5
us
over
and
square root
like
of
our
50.
art,
So what's the answer?
so that everything that we do will be just enough for you there.
Okay,
Thank you
so
for the gift of life.
using your calculator,
This is the
try
answer.
to find the test statistic for Z. That is, okay. So the answer would be negative 5.66. So what is step number 4? Okay. So H sub A is what? Mu is less than 87. So since we are using less than symbol, it is directional. And again, if it's directional, it's a one-tailed test. Now, since we have an alpha level of 0.01, let's go back to the slide wherein we have the matrix. So where was that? Okay, so since we have an alpha level of 0.01 and it is one-tailed, therefore we have a critical value of 2.33. So Z is 2.33. Now, let's graph our um, our critical value and our test statistic in the normal curve. Okay, so let's graph the normal curve. Again, since we are using less than and it is pointing to the left, therefore our critical value is at the left side of our normal curve. So we have 2.33. So this would be here. Ayan. So this is negative 2.33. Since it's in the left side, it will become negative. And then, so here would be our test statistics. So that would be negative 5.66. Again, give a statement. Obviously, our test statistic is in our, or it lies on our rejection region. So since the test statistic lies on the rejection region, we will reject the null hypothesis. Okay. Hence, let's proceed to step number 5. The average grade of a fifth grader in math is less than 87. So this is our process of how to test hypothesis in step number 3. So if you have questions, class, feel free to message me in Messenger or in our GCs since we have our GCs. And um, the slides to be used is actually uploaded in the Google Classroom also. So for your assessment, please check the assessment in the week number 6. Okay? So that would be all in this lesson. And I hope that in the future, we will be having a synchronous class. So that would be live online in real time. Because as of the moment, I haven't met you on the schedule because of some things that we need to discuss with or to talk with. Okay? So that would be all. Thank you for listening.